The distance between two cities is 900 kilometres to the nearest 100 kilometres. Complete the error interval for the distance. So I know it's 900 kilometres. The first thing I'm going to look at is what it's been rounded to, and it's to the nearest 100. So I'm going to look at the 100 below, which would be 800. And the 100 above, which would be 1000. And then I'm going to think, what is actually smack in the middle here? At what point do we stop rounding to 800 and start rounding to 900? Well, that would be 850. And again here, at what point do we stop rounding from 900 and start rounding to 1000? Well, that would be 950. Now this actually makes up the numbers that are in my error interval, and my error interval looks like this. There's an X in the middle, or it could be an N, that stands for what our number that can be between this. So this is our number, and it's going to be bigger than 850 or equal to 850, because 850 would round up to 900. Now it's not actually going to be 950, because 950 would round up to 1000. But it can be 949. It could be 949.5 kilometres. It could be 949.6 kilometres, 0.7, 0.8, 0.9, 949.999999999 kilometres. So instead of putting a lot of nines, an infinitive amount of nines, we put an equality symbol without the equal sign. So this bit in blue is my error interval. Now this bit here is what we call my lower bound. And this bit here is what we call the upper bound. Let's have a go at another. A number n is rounded to 2 decimal places. The result is 6.27. Using inequalities, write down the error interval for n. So I'm not going to use x this time because it's told me to use n. But before I do that, I need to think, well, my number is 6.27. That's once it's been rounded, and that's been rounded to 2 decimal places. So the 2 decimal place is, second decimal place is this one here, it's the 7. So I need to think, well, if it was 2 decimal places lower, then it would be 6.26. So it's the second decimal place that's changing. And a second decimal place above would be 6.28. And then again, I start thinking, right, well, at what point do I stop rounding from 6.26 and start rounding to 6.27? Well, that's bang in the middle. It's going to be 6.265. And at what point do I stop rounding from 6.27 and start rounding to 6.28? Well, that's going to be 6.275. So I'm using n because it told me to. And my number is going to be anywhere between 6.265 and 6.275, but it can't be equal to 6.275 because that would round up to 6.28. It can be equal to 6.265. And again, this bit here would be my lower bound, and this bit here would be my upper bound. The last one I'm going to look at is when it's rounding to significant figures. So this time I've got a number y, so we're using y this time, is 15,000 when it's been rounded to 2 significant figures. Write down the error interval. So my number is 15,000 once rounded. It's been rounded to 2 significant figures. Now the first significant figure would have been this 1. The second significant figure would have been the 5. So it's the 5 that has possibly changed. So if that was the figure below, it would be 14,000. So it's that one that's either 14,000 the 5's changed to a 4, or it's gone to the one above, it's gone to 16,000. And again, this is where I start thinking, right, at what point do I stop rounding to 14,000 and start rounding to 15,000? Let's bang in the middle, it's 14,500. And at what point do I stop rounding to 15,000 and I start rounding to 16,000? Again, bang in the middle, 15,500. We're using y because it told us to in the question. It's between 14,500 and 15,500. It can't be equal to 15,500 because that would round up to 16,000. But it can be equal to 14,500. Again, so that's my error interval. This is the lower bound and this is the upper bound.